Hi everyone. In this video, we are going to do a comparison between replicating portfolio and delta hedging approach that we learned. The first method that we learned was of course the delta hedging method, and the second one that we learned was replicating portfolio. So we're going to do a comparison between the two approaches and then arrive at certain conclusions. All right. The third approach, which is the risk neutral valuation, is completely different from replicating portfolio and delta hedging. Whereas replicating and delta hedging are actually, if you look, have very stark similarities. All right. So the first similarity is both of them deal with delta shares. In delta hedging approach, if you recollect, we started off by creating a risk-free portfolio. I'm going to give examples of call option because that is what we have done. Okay, the put option example, I will probably take it in the next video. But to be honest, the put option is actually calculated using the put call parity equation. We generally do not use delta hedging and replicating portfolio directly to calculate the value of put option. We generally use it for calculating the value of call option, and put option is backed out using the PCP equation. Okay, so under the delta hedging approach, we actually wrote a call and we were holding delta shares, right? Okay, whereas in a replicating portfolio also, although we didn't start off with holding delta shares, what we did was we tried creating a portfolio that replicates the payoff of that of a call option, right? The payoff of the replicating portfolio, we ensured that it equates the payoff of the call option at upper node as well as bottom node. Okay, how did we do that? We assumed that we would borrow a sum of y, sum of my y meaning an amount y, and we would buy h shares, right? So buying h shares and borrowing a sum of y, right? We then had, so these were, we had two unknowns, which means we have two variables, and then we had two equations as well. The first equation, we got it as by equating the payoff of the replicating portfolio with the payoff of the call option at the upper node. The second equation we got by equating the payoff of the replicating portfolio with the payoff of the call option at the bottom node. Okay, so we had two unknowns, and then we had two linear equations. We solved for them, and then we found out that h was nothing but equal to delta of the share, right? So although we didn't start off with delta, we started with the notation h, but when we solved for h using linear equation, we found out that h was also equal to delta. So under both the approaches at t equal to 0, which means today, we hold delta shares, right? Because under delta hedging approach also, we were holding delta shares, and under the replicating portfolio approach also, we were borrowing and we were holding delta shares. Okay, so the first similarity is we were holding delta shares in both the approaches. Coming to the second similarity, I'm not sure how many of you actually noticed. In delta hedging approach, the payoff of the risk-free portfolio, this portfolio that we built, which is writing a call and holding delta shares, that was a risk-free portfolio because its payoff was the same at t equal to 6, whether the share price was 55 or whether the share price was 45, right? So we call that a risk-free portfolio. The payoff of this risk-free portfolio was 31.5 at t equal to 6 at the upper node as well as at the bottom node. Under the portfolio replication also, if you see the value of y, where y refers to the amount of borrowing at t equal to 6, which was 31.5. And time and again I've stressed on the fact that value of y, which is borrowings plus interest at t equal to 6, is going to be the same at the upper node as well as at the bottom node, because the value of a share does not determine how much you have to repay as borrowings plus interest, right? So value of y at t equal to 6 is nothing but the amount of borrowings that you have to repay at maturity, which includes interest as well, right? So under the delta hedging approach, what you got as payoff of the risk-free portfolio at t equal to 6 is equal to the principal plus interest that you have to repay at t equal to 6, right? Obviously, when there are cash flows which are equal at t equal to 6, the present value of those cash flows at t equal to 0 will also be the same, right? The present value of 31.5 is equal to 30.73 under the portfolio replication approach. This 30.73 is actually nothing but the amount of borrowings that you have to make today at t equal to 0. 31.5 was principal plus interest. When you're discounting the principal plus interest with the discount rate, what you get at t equal to 0 is the principal amount itself, right? So 30.73 is the amount of borrowing that you have to make today. Under the delta hedging approach, when you discount the payoff of the risk-free portfolio, when you're discounting any cash inflow standing at future date, what you get today is the price of that portfolio, right? For instance, in bond, when you discount future coupons and face value, what you get today is the price of the bond. Similarly, over here you have a cash flow of or a payoff of 31.5 standing at t equal to 6. When you discount that, what you get is 30.73, which is the price of the risk-free portfolio. If you pay 30.73 today, you are certainly going to get 31.5 at t equal to 6, right? So 30.73 is nothing but the investment that needs to be made today, or the price of the portfolio, right? The price that you need to pay to receive a certain cash flow of 31.5 at t equal to 6. So that is the second similarity. The amount of risk-free investment in the delta hedging approach, risk-free investment meaning nothing but the price of the portfolio. What you pay as the price of the portfolio is risk-free investment today, right? Is equal to the amount that needs to be borrowed under replicating portfolio approach. And this I'm talking in today's terms, right? Over here also, the risk-free investment was nothing but the investment being made today. That's the price that you have to pay at t equal to 0, is equal to the amount of borrowings that you have to make at t equal to 0 again. Obviously, when there are cash flows which are equal at t equal to 0, they have to be equal at all the timelines, right? You will have the same cash flow at t equal to 6 also, obviously, right? So we saw that there are two stark similarities between replicating approach and replicating portfolio approach and delta hedging approach. Is that rocket science? See, if you actually imagine, we're calculating the value of a call option, and please remember that the value of a call option has to be equal irrespective of the method that you're applying, whether you're using the risk neutral valuation, whether you're using the delta hedging, or whether you're using portfolio replication, the value of the option has to be the same. You cannot have three different values of a call option just because you have used a different method, right? We are still using the binomial method, and under binomial method, there are three approaches, and the value of a call option has to be the same under all three approaches, right? Like I said earlier, risk neutral valuation is actually very, very different from replicating portfolio and delta hedging. Okay. That does not have any similarities to when we compare it with replicating portfolio or delta hedging. Whereas when you compare replicating portfolio with delta hedging, we saw that there are really very, very close similarities. Is that actually rocket science? The answer is no. Let me actually, although I've plotted it down on the slide as well, we'll go through that. But before that, I would actually show it to you as to why, you should not be surprised because of the fact that we saw the 31.5 and 30.73 were the same values under replicating portfolio and under the delta hedging approach. And even when we calculated the value of H under the portfolio replication, it turned out to be the value, nothing but the value of delta, right? You should actually not be very surprised because replicating portfolio and delta hedging have been derived from one another. How? Let's look at it. Under the delta hedging approach, sorry guys, I'm still getting a little accustomed to write a little more faster on this board. Until then, please adjust. Under the delta hedging approach, what we did was we wrote a call option, we write a call option, and we were, wow, what was that? Sorry. And we were holding delta shares, right? Holding refers to buying, right? And when we were doing this, when we were writing a call option and we were holding delta shares, we saw that that was building a risk-free portfolio, correct? So if I put it in other words, value of a risk-free portfolio is equal to value of delta shares minus value of a call option. Okay, the reason I've used minus over, Sorry again for that. Okay, the reason I've used minus signage over here is because I'm denoting that we have a premium that we're actually receiving when we are writing a call option, right? Okay, so actually over here, the signage that I've indicated is opposite to what we actually have cash flows, right? Because when we buy delta shares, we have a cash outflow, but I've denoted that cash outflow as a positive signage. When we write a call option, we have a cash inflow, but I've denoted that cash inflow as a negative signage. Okay, and value of a risk-free portfolio, we saw that we actually have to pay 30.73 under delta hedging approach. We have to pay 30.73. So 30.73 was actually a cash outflow today. If we pay 30.73 today, we receive 31.5 at t equal to 6, right? So 30.73 also, if you look at it, was actually a cash outflow, but I've denoted it as positive signage, right? So I'll just write it down in the brackets for you to remember later. Positive is outflow, negative is cash inflow. Okay, so the negative signage over here is actually the premium that I'm receiving on call writing, right? Okay, so we saw that the value of a risk-free portfolio is equal to value of delta shares minus value of a call option, right? And how did I write this equation down? Because we started in delta hedging approach by writing a call and holding delta shares, right? And we saw that we actually proved that when we write a call and hold delta shares, the payoff of that portfolio is going to remain equal whether the share price is 55 or whether the share price is 45, which means writing a call option and holding delta shares is actually a risk-free portfolio. Okay, so that I've basically assigned values to it, which is value of a risk-free portfolio is equal to value of delta shares minus value of a call option, where I've denoted plus as cash outflow and negative signage as cash inflow. So minus minus value of call option represents the premium that I'm receiving on account of writing a call option, right? Now, this was the equation for delta hedging. Okay, all I'm doing is rearranging this equation as value of a call option is equal to value of delta shares. So what I've done so far is this minus V of C, I brought it to the LHS to make it plus V of C, right? Value of delta shares, as I've kept it as is. I'm bringing value of risk-free portfolio to the right side, right? So I've done nothing but interchange V of C with V of RF, right? I took V of C to LHS and I brought V of RF to RHS. So value of a call option is equal to value of delta shares minus value of a risk-free portfolio. If you actually look at this, this is nothing but portfolio replication approach. How? A call option, sorry, give me a second again. Yeah, a call option is equal to, we saw that it was nothing but buying delta shares financed by borrowing a sum of money, right? Which means buying delta shares, again, the signage is the same as what it is above. Okay, when I'm buying delta shares, it's a cash outflow, which is denoted as positive sign. By borrowing a sum of money, when I borrow money, I receive cash, right? It's a cash inflow, but I've denoted it as a negative signage, right? So value of a call option is nothing but buying delta shares by borrowing sum of money, which is nothing but this, right? Borrow and buy delta shares, right? Okay, so if you actually see, all I did was in the delta neutral method, we had a certain equation where the value of a risk-free portfolio was equal to value of delta shares minus value of a call option. all I did was move value of call to the LHS and move value of the risk-free portfolio to the RHS. When I did that, what I exactly arrived at was the portfolio replication, because value of call option is nothing but borrow and buying delta shares, where the amount of borrowing is slightly less than the amount of cash outflow on buying delta shares, right? So when you buy delta shares, suppose you incur a higher amount. Let us take the values that we actually have over here. Under the portfolio replication approach, you borrow a sum of 30.73, whereas the uh, give me a second, where is it? Yeah, so you borrow 30.73. Okay, so 30.73 was your cash inflow, whereas the value of delta shares was 50 into zero point 0.7, right? Which is 35 minus 30.73, right? So the value that you're actually borrowing is less than the value, the amount that you're receiving on borrowing is actually less than the amount that you're paying for buying delta shares. Okay, this is equal to, we got it as 4 point some 3 what 37 or something, right? 4.27, sorry, yeah. Okay, this we said is the value of call option. This positive signage, if you actually see, is a cash outflow, right? Because I've denoted positive amounts as cash outflows and negative amounts as cash inflow. And what we were saying was this 4.27 is nothing but the value of a call option, which is nothing but the amount that the holder needs to pay to the writer for buying a call option today, right? So if you look at it, the portfolio replication model and delta neutral method have been derived actually from one another. It is just interchanging of equations, right? So, I mean, obviously, you should not consider it to be rocket science when you saw that in the delta hedging approach, the price of the risk-free investment was actually equal to the borrowing that you made today. It has to be equal because all you did was you moved value of risk-free investment from LHS to RHS, right? When it is in the LHS side, it was risk-free investment. When it came to the RHS, it became risk-free borrowing, right? The value obviously will remain the same. It is 30.73, whether it is on the LHS or whether it is on the RHS. What changes is it was an investment here, whereas it becomes a borrowing here, right? Similarly, value of a call option, over here you were assuming that you're writing a call option, and that is why we had a negative signage. Whereas in portfolio replication approach, we did not assume that we were writing a call option. We were thinking from the point of view of a holder of a call option, right? That is because we moved the value of call from RHS to LHS. So that is the reason, like from a writer position in delta hedging, we were thinking from the point of view of a writer, right? Because we started off saying writing a call and holding delta shares. Whereas in a portfolio application, we were thinking from the point of view of a holder, right? It's just because of the fact that we moved it from the RHS to the LHS, right? These are the same points that I mentioned in the slide as well. Let's quickly go through that. So the stark similarities are, the stark similarities that we saw were delta was equal under both the approaches, and the risk-free investment in delta hedging was equal to the amount which we borrowed today. Under the delta neutral method, the value of a risk-free portfolio is equal to value of delta shares less value of call option, right? We did minus over here because we are receiving cash when we are writing a call option, right? So if this is an equation in math terms, if I have to put it in words, it is nothing but writing a call and holding delta shares is nothing but equal to holding a risk-free investment, right? If we move value of call to the LHS and value of risk-free portfolio to the RHS, you would get value of call is equal to value of delta shares minus value of the risk-free portfolio, right? This minus value of risk-free portfolio denotes borrowing that you have to make today. In the above equation, it was on the LHS side having a positive signage, where that positive actually denoted risk-free investment, right? Over here, the negative signage denotes borrowing. Borrowing meaning a cash inflow today. value of call in delta hedging method, you were thinking of it from the viewpoint of a writer of a call option. You were selling a call option. Whereas over here, you're thinking from the viewpoint of a buyer of a call option. That is the only difference, if you ask me. Okay, I mean, so I'm replicating portfolio itself is actually derived from delta hedging method, or you can otherwise say vice versa as well. Delta neutral method was denoted from replicating portfolio approach, right? So you should not be surprised that you have these similarities, because they're actually nothing but they're coming in from the same equation. You're just changing the sides, right? I mean, remember that Akshay Kumar's meme of this one? It's exactly like that. Okay, those of you who understood, very good. Those of you who did not understand, forget it. Okay, so please don't be surprised when you see that the values that you're dealing with in delta hedging and replicating portfolio are one and the same. Of course, I'm not talking about the end value of a call option. The end value of a call option has to be the same by hook or crook, right? I mean, that cannot be different. Even under the risk neutral method, you will have the value of a call option the same as what you're getting under the delta hedging and the replicating portfolio. But in the replicating portfolio and delta hedging method, your process of calculating call option also has a lot of similarities that we already saw. Okay, don't be surprised by it, because it is coming in from the same equation. So what we are going to do, this is going to be the end of this lecture. I'm going to keep it short. In the next lecture, what we will do is we will take a pause. We will try solving a couple of sums on the basis of these two approaches. Okay, and we will also try and solve a sum for put option. Although, like I said earlier, put option is generally backed out from put call parity equation. Still, we'll try solving a sum on the basis of put option under the delta hedging as well as replicating portfolio. Okay, so probably in the next video I will only be doing some question solving, and you will have to bear with my writing on this whiteboard. I hope it is improved. God knows, I will try working on it. Okay, and after that we will continue with the risk neutral method. Thank you guys.